The collaborative 3D Web Viewer and iVisual are two specific enablers from the FITMAN project to create future Internet 3D applications. The collaborative 3D Web Viewer can be used to assemble static 3D scenes, while the iVisual can be used to simulate dynamic data-driven processes. In this example, we are going to show how both enablers could be employed to create a simple planning and simulation application within the context of a production facility scenario. In order to simulate human worker behavior, we are going to attach an external multi-agent system to the iVisual. To be able to configure this simulation, the collaborative 3D Web Viewer is extended by a configuration component. The FITMAN catalog offers links to the software repositories of the specific enablers. As open source frameworks, the source code is publicly available on GitHub for everyone. The developer, especially the Phase 3 web entrepreneurs, can use these links to clone the repositories. The collaborative 3D Web Viewer is based on a generic entity component system that enables developers to attach any application-specific data to 3D objects. This, for instance, can be used to attach annotations or to describe agent behavior. Being a modular framework, the collaborative 3D Web Viewer enables developers to build custom solutions on top of the building blocks of the system. Every collaborative 3D Web Viewer component is comprised of two parts, the back-end application logic and the user interface. In this example, we use an existing multi-agent system and attach it to the iVisual. Every component of the iVisual will be synchronized between all clients automatically. Thus, the simulation is available to all clients. Now, the collaborative 3D Web Viewer can be used as part of the newly developed application. In the example shown, it is used to add agents to the 3D scene and configure their behavior. From the Web Viewer, this scene could be sent to the iVisual for simulation. A production planner, for example, can now use the developed application based on the combined SEs in order to simulate a simple production process. In the scenario shown, a machine consumes material in order to produce a good. At a certain point, there is a lack of material in the production process. The agent fetches the needed material and provides it to the machine. For the simulation, the agent behavior can be configured by using the newly developed agent component of the collaborative 3D Web Viewer. Therefore, a user just needs to specify where the agent has to move in order to pick up the material and where to place it. Then, from the collaborative 3D Web Viewer, the simulation is started. With the dynamic visualization of this process, the user is now able to do and decide several things using the iVisual. For example, a production planner can calculate the time needed to refill the magazine. Together with information about how often this event occurs, she can plan the time needed to produce a specific amount of output more accurately. This is useful for production planning, in particular if the production line is not implemented in reality yet and therefore direct time measurement is not possible. Furthermore, she can discuss such events directly with other users from her company, even if they are at the other end of the world. Due to the possibility to synchronize the simulation across browser instances, everybody can see the same process. No special software is needed to run and synchronize the simulation. All you need is a web browser, which is a user-friendly environment without any further investments like license fees for special software. In our example, the refill time of the machine could be improved. The production planner can go back to the collaborative 3D Web Viewer and replan the production setup collaboratively. As a consequence from the first simulation process, she decides to move the machine closer to the material storage. With this new setup, the simulation could be rerun. In the new setup, the production process is improved. By using the information from the multi-agent simulation, it is not only possible to simulate the production process, but also to directly affect it. As future scenario, for example, it could be possible to create a guideline for a blue-collar worker out of the information from the agent. In this way, it would be possible to inform the worker, for example, via her smartphone. Shortly before the magazine is empty, she can refill the magazine directly in order to prevent longer downtimes in the real production process.